So in the first part of this video, we learned how to take this word problem and set it up into this system of equations. So in this part of the video, we're going to go ahead and solve this system of equations. So as I said in the first part, the next step we would have to do is to distribute this. We cannot solve a system of equations if we have sets of parentheses. So we're going to distribute this 10 to the c and the s. We can do that because by having no space here, we are technically multiplying 10 by the set of parentheses. And then we're going to distribute the 70 to the c and the s. At this point, a lot of my students before were thinking, well, we're going to end up with kind of the same exact thing. That's not necessarily the case because here we have a plus and here we have a minus, so it is going to be slightly different. So once we distribute that, we're going to get 210 equals 10s plus 10c, and then 210 equals 70s minus 70c. So the idea is to figure out what do we need to do to one of these equations in order to get the variables to have the same number in front but different signs. So here's a clue. Here we have different signs in front of the c. So this would be the ideal thing to cancel out. It wouldn't be incorrect if you wanted to cancel out the s, but it's only possible if you multiply by a negative. So here we got to figure out what do we have to do to make these two numbers in front exactly the same. Well, I know if I multiply 10 by 70, we'll be able to make them exactly the same. So I'm going to go ahead and show you how to do that. So I'm going to take this whole equation and I'm going to multiply it by 7 because 7 times 10 is 70. Once I do that, I'm going to end up with 1,470 equals 70s plus 70c. And I'm going to go ahead and take this equation below and just rewrite it again underneath so that I have it written down. It's 210 equals 70s minus 70c. So when we're solving a system of equations, what we're going to do is we're going to take the system, add the equations together, and ideally what should be happening is these two should cancel out. 70c minus 70 just ends up being 0. So then we have to add the numbers on the left-hand side of the equation and then on the right-hand side. So here we end up with 1680 equals 140s. And what I'm going to do is I'm going to go ahead and move this to the top up here just to save some room. So that's supposed to be an arrow, I promise. So we have 1680 equals 140s. And in order to get that s over here by itself, we have to divide both sides by 140. So when I divide both sides by 140, let me plug it into my calculator real quick and see what we get here. I'm going to end up getting s equals 12. So what that's telling me is what I did was when I set up in part 1, when I set up my variables, s represented the speed of the boat. So it's telling me that my boat is going 12 miles an hour if the boat was in still water. So from here we got to figure out the speed of the current. So here's the cool thing that I like about solving systems of equations. We can take this value of s and we can plug it in anywhere. We can plug it into one of these equations, we could plug it into one of these equations, we could even plug it into this equation up here. So I'm going to go ahead and do this in a different color just to distinguish we have a new equation going on here. And I think what I'm going to do is I'm going to go ahead and use this equation right here before we multiplied by 7. So I'm going to plug it in there. So that gets me 210 equals 10s plus 10c. Notice how instead of plugging in s, I just left a blank because what I'm going to do is I'm going to plug in my 12 that I just found. Since 12 equals s, I can easily plug it into there. It technically means the same thing, so there's nothing wrong with that. So once I go ahead and simplify this, I end up with 210 equals 120 plus 10c. I got to get c by itself. I got to solve, so I'm going to subtract 120 from both sides. 210 minus 120 is going to give me 90. So 90 equals 10c. Divide both sides by 10. I barely have enough room for this. So 9 equals c is what I'm going to end up getting. So these are my two final answers. So what it's telling me is If the boat was in still water, it would be going 12 miles per hour, and the speed of the current while the boat is traveling is actually 9 miles an hour. So you can see these are pretty close in times. One is 9, one is 12. That's not too much of a difference. And that kind of explains why the trip back took 70 hours in comparison to that 10 hours. So it took so much longer because if you subtract the currents, you find out, well, the boat is actually traveling only 3 miles an hour going against the current. So that's not very fast at all. So that's essentially how you do the entire problem. If you have any questions, go ahead and reply to the post.